You said that a ray is a path taken by uh, light, or the direction taken by light. That's what we call a ray, and it is normally uh, defined by a straight line with an arrow, and the arrow shows the direction or the path the light takes. So we have a ray and a beam, Now, from there, we're talking about beams or a beam. That's under the beam. A beam is a collection of rays. So it's just not a single one. When it becomes single, then we are talking about a ray. Now, a collection of them, we call it a beam. Now, these beams, they can be grouped into three main types of beams. We have the parallel beam, or in other words, parallel beam. All right. That's a convergent beam. That's a divergent beam. Now, when we say parallel beam, then you are trying to say that these are beams. Let me talk of parallel beams. These are beams that, or in other words, parallel rays. So when you say rays, they are rays under the beam. The rays under the beam, they do not meet. Oh. So when you have rays, a group of rays that do not meet, we call them parallel beam or parallel rays. So that is it. They do not meet at a point, and they are equally spaced normally. That's why they cannot meet at a point, and they may move in the same direction. So we can talk about this parallel beam, and we can also talk about convergent beam or convergent rays. Now, when we say convergent beam, they are rays which meet at a point. So this one, the rays meet at a point. They converge. It comes from the word converge. They meet at a point. So we have this. So we have something like the convergent beam. Convergence beam. So they converge at the point. So in this beam, the rays converge at a point. I hope I've made myself clear. Now when we say divergent, they diverge or they move from a point. So divergent, they move from a point. Divergent, they move from a point. They move from a point, so they diverge. So we have the divergence beam, we have the convergence beam, and we have the parallel beam. So these are the things we have. I hope you are done drawing them. You can draw them. When you're done drawing, you tell me so that we continue. Hi Dan.
Yes, sir.
Ruben, hi Dan.
Yes, sir.
Oh, you can tell me some more.
Yes, sir.
What time should we close? Because we have class at 11. What time should we close? It's almost 10. Should I leave you so that you go and prepare for the next class? Huh? So that the next time we do the pinhole cameras and so on and so forth. What do you think? Pinhole cameras and magnification. Casey, what do you think?
So let's finish the pinhole camera.
You said?
Let's finish the pinhole camera.
Okay. Ruben, what do you think we should?
Okay.
Should we finish the pinhole camera?
Yes, sir.
Okay, so let's talk about pinhole camera. Now, the pinhole camera, the operation of the pinhole camera is a direct example of an application of rectilinear propagation of light. It's an application of rectilinear propagation of light. So application of rectilinear propagation of light. So number one application is we are going to talk about the pinhole camera, the operation of the pinhole camera, the pinhole camera. Now, we can talk about formation of shadows, formation of, and another formation of shadows. We can talk about eclipse formation. I'll talk about eclipse formation. So now let's talk about the pinhole camera. Pinhole camera. Let's talk about the pinhole camera. Pinhole camera. Now, those days, or in the old days, they were using the pinhole camera. Now, when we say the pinhole camera, the word comes or the name was gotten from the size of what do you call it? The hole of the camera. Let me put it that way. And so we are saying that the hole there has a pinhole. When you say a pinhole, that means the size of the hole is that of a pin. It can be compared to that of a pin, the size of a pin. I get what I'm trying to say. Eh? That is
Yes, sir.
when we are talking about the hole, we are talking about the opening where the light passes through, and that is so small that it can be compared to the size of the pin. That is why we call it pinhole camera. You get it? A camera that has its own being like the size of a pin. That's what we call the pinhole camera. And I think that's the first one they developed to take pictures and so on and so forth. Now, the pinhole camera is made in such a way that uh, it is made up of a light, uh, tight box. This is a light, tight box. And in the light, tight box, it has one side which forms the screen, or one side which is the screen. And the screen is where the image is formed. or on the screen is where the images are formed. And normally it has the other side where the light passes through, which is the hole of the pin. Then we will have to come and talk about the object in question. So for instance, object never be taking a picture now. We also are going to talk about that. Then from there, we are going to talk about the distance from the object to the pinhole. And we're also going to talk about from the hole to the screen in the box. We're also going to talk about the distance. And so yeah, we are going to talk about. I'll just explain briefly so that next time we meet, we are going to do the arithmetic and the properties of a pinhole camera and so on and so forth. And so that's a so this is the hole. Now inside the hole, this part has a screen. This part has a screen, and a screen is where the images are formed. I hope you getting me. So this the screen is where the images are formed, and here this hole is what we call the pinhole. This is what we call the pinhole, and that is where the light passes. The light passes. And let's say so if I have an object here, this can be of you. So we have this. Now when we have this and light rays are this thing, what do you call it? Light rays will pass through because we want to make sure that we get an image of this on this thing. Definitely the light will pass through this and it will reflect the what do you call it, the images on this. Uh, so that is basically how it's going to be. And so I'm going to get something like this. Then we are going to talk about something like this. You can also have some of the light passing through this. The light is what reflects the image. What reflects the image. Now, these are rays. What I've drawn are rays. I'll just have to add arrows to show that they are rays. So there's a pinhole. There's a full camera. In the camera, we have the screen where the images is formed. One light rays, what do you call it, passes through. Or light rays does not what do you call it. Because this is an opaque object, the light doesn't pass through. Rather, it absorbs it and reflects. You get it, and reflects it through the hole, and it is formed. The image of this is formed on the screen. On the screen. So that is it. Now, this so this is the object. There's the object. Now the image is formed here. When the image is formed, the image is turned. This we call it inverted. Call the image is inverted. That's how it works. So when you see this now, the distance from the image from the object, to the pinhole, the distance from the object to the pinhole is what we call the object distance. Object distance. The distance from here to here is the object distance, and it is denoted by u. It is denoted by u. Let me change the color. It is denoted by u. So the distance from the object to the pinhole is what we call the object distance, and it is denoted or represented by u. Now, the height of this image, the height of this object is what we call the object height. The height of this, we call it object height, and it is denoted by h naught. So object h0 like that, ho, object height. We call it h naught. There's the object height, the height of the object. Now the distance from the pinhole to the distance from here to here is what we call the image distance. So the distance from the image, the pinhole to the, what do you call it? This is what we call the image distance. So this we call it, this is denoted by V, and we call it image distance. So here is image distance. Now the height of the object, the image from there, the height of the image from here, we call it image, what do you call it? Image height. Image height. So the height of the image formed here is what we call the image height, or the height of the image. Now the distance from here, the pinhole, to where the image is formed, which is in the box, is what we call the image distance. Now from the pinhole to where the object is standing is what we call the object distance. The height of the object is called the object height, which is denoted by h naught. I hope I made myself clear. Now, this is how it works, the formation of the image. Light travels from one point on the object. So light travels from one point of the object into the screen at the back. So into the screen at the back. Now, one point on the object corresponds to a particular point on the image. That's what we said. And this leads to the production of the image. Now, when the pinhole is enlarged, when this pinhole is enlarged, the image formed is normally blurred, because let me explain why. When the PO is enlarged, the image becomes brighter but blurred. So it becomes brighter but blurred, in the sense that a large hole is like, when this hole is large, the hole behaves like it were, or is a combination of 2 or 3 holes. As a result, different images will be formed on this. Because it acts like a combination of 2 or 3 holes, light will just be able to pass through any of the holes, and as a result, a series of images will be formed on the screen, and that will make it very bright because it is large, but then it will make it blurred because a lot of images are formed on it. So to be able to get a sharp image, it is normally advisable that you get what do you call it, a very small size, or the pinhole is very small. That is why even with our normal cameras, when you are snapping someone and you zoom it, you realize that you get a bigger picture, but it becomes blurred. Have you noticed that? Have you noticed that? Ruben, have you noticed that?
Yes, sir.
Yes, but
Yes, sir.
when you don't zoom it, you realize that sometimes when you don't zoom it, the picture is small, but it is very sharp. You get a good quality of the picture. It is very sharp.
Yes, sir.
Exactly. So that is it. Now let's talk about characteristics of images formed by a pinhole camera. We are saying that images normally formed by a pinhole camera, they are real. And when we say images are real, that means these are images that can be gotten. You can be able to get it. You realize that when I take you a picture with my camera, you can be able to get a picture. You can be able to print the picture. You can be able to get the picture in a soft copy. So when we say images are real, that's what we mean. And these are images formed on a screen, so they are real. Now they are also diminished. You realize that this image, the size of this is smaller than this. So when you take a picture, you don't get your full body on your phone, but you get a smaller size of your full body that represents your full body. So normally the images are small. So the images are small. In other words, we say they are diminished. They are smaller than the object size. Now the images are inverted. When you say inverted, they are turned upside down when they are taken. So these are one or two properties, or one or two characteristics or features of images formed by a pinhole camera. Now I've also explained or reiterated what do you call it, the brightness of an image in a pinhole camera. I said that with the brightness, it normally depends on two things. It depends on the size of the pinhole and the distance. So the brightness of the image will normally depend on the size of the pinhole camera or the distance. Now, when you increase the size of the pinhole, it increases the brightness of the image and vice versa. So realize that when you increase it, it will increase the brightness because a lot of light will be able to pass through. And as a result, it will increase the brightness. But you are going to get the picture to be blurred, but it is bright. Number two, it also depends on the distance of the object. So you realize that when the object is very close, you definitely, you are sure that you are going to get a good snap or a good shot. as compared to when the distance is further away from the pinhole camera. I hope you bear with me in that way or in that sense. So the closer the object to the camera, the brighter the image, and vice versa. That is it. The sharpness of the image normally depends on the size of the pinhole camera as well, and the distance as well. So you can also talk about the size of it. I said that when the pinhole is very small, it gives you a good shot or a good a sharp image formation. Now when it is very big, it becomes blurred. It becomes bright but blurred, and so that is it. That is it. Then uh, I think that is it. We can also talk about the advantage of a pinhole camera. Now the main advantage of a pinhole camera is that it does not require focusing by way of adjustment. It does not really require focusing by way of adjustment, and that is no matter how far or close an object is, the image is formed. So no matter how far or close an object is, still the image will be formed. That is it. So that is one advantage of it. In view of this, the pinhole camera is said to have an infinite depth of focusing. So no matter the height, the size, or anything, it's still the image will be formed. Now, one disadvantage of it is that because the hole is small, the amount of light energy that enters the camera is very small. So the camera takes a longer time to form an image on the screen. Because the distance is small, because the image is small, it takes a longer time for light to be able to pass through and listen. So as a result, it takes a longer time for us to form an image on the screen. Now the camera also must always be covered with a black cloth. And what they do is, as at those days, they always covered the camera with a black cloth so that they prevent light from passing through other sources or other parts of the distance to enter the distance that might affect what do you call it, the image production. So the camera must always be covered with a black cloth to prevent light entering the camera through the sides and the edges, so that we cover it so that it prevents further light from passing through the camera from other points, especially when there are leakages or something. So that is it. So next week we are going to talk about the mathematical representation of this pinhole camera. We are going to talk about magnification. We finish it and we come and talk about shadows and eclipse formation. Then from there, after that, if we have more time, then we'll talk about reflection of light. I hope I've made myself clear.
Yes, sir.
So thank you very much. Go and prepare for the 11th class. We are doing commerce today, statistics. So humbly go and prepare for it. Yeah. Thank you very much. Ruben, have you told Ruben? Ruben,
Sir.
have you told
Yes.
mommy? Have you told mommy that you started a private class?
Yes, sir.
Okay. Thank you. So we talk.
But
Prepare.
sir, please can you send me the recording of the class?
I've been putting it on YouTube. Is it of this
No,
one?
no, this one. Yes.
Okay, this one I have not played. I'll do it. I'll put it there so that you go and have it.
I thought you send it to me rather.
On WhatsApp.
Yes.
It is very. I've been trying to do that, but I think I'm not getting how it works. So I'm able to this now. I'll put it on YouTube so that you go and download it. Initially, that's what I wanted to do, but normally transferring to my phone is a problem because I would have to transfer it to my phone before I can send it to you. You
Okay.
get it? So that is why I
Yes.
normally put it on this thing. I'm trying to see if I can put it on Google Drive so that I give the link, then you go there and go and watch or something. But let's see how it
Okay.
works. Thank you very much.
Okay. Bye.